In this next video, I'm going to show you an example of how to find the intersection of two lines using the fsolve function. So following the last two examples, we have the equations y minus 3x equals 2 and y plus 2x equals 7. So fsolve is a function that can solve systems of equations that are both linear and nonlinear and have many variables. So in this example, I'll show you how to use linear equations, but it can be easily adapted to nonlinear, as I'll show you in another video. So as I said, we're going to use the fsolve function to find the intersection. So the way this works is you write a function that has the equations that you're working with, and the input to that function will be a vector containing the variables. In this case, it'll be y and x. If that doesn't make a lot of sense, I'll just show you an example. So in this, we'll just write an internal function. So we'll make that equations function is going to be a function of our variables, so at var, and then we're going to use a matrix with two rows, and the first row is going to be our first equation. So that will be var1, which corresponds to y, minus 3 times var2, which will correspond to x, and then so we have to rewrite these equations. I didn't explain that. So we have y minus 3x minus 2, and then y plus 2x minus 7. And so then this will be minus 2, and then we'll have var 1 plus 2 times var 2 minus 7. And so if that's hard to see, basically we have y, which corresponds to our var 1, and then x, which corresponds to our var 2, and then this last column is our solutions. So it's a 2-row single column matrix here that we have, and it's going to output the value of y and x. So we've defined our function, and now we have to define the points that we want to start at. And so that's just going to be in a variable called initials, and that's going to be 0, 0. And note that I used this semicolon here, which will correspond to, so it's a column vector, column matrix containing our initial xo and yo, and so. Yeah, so the way the fsolve function works is, as I said, it's going to put out a value for this x and y when these two functions are equal. So we'll have solutions equal fsolve, and then we'll have our equations function, and then our initials, and then this next part you don't really need, but I'm just going to write it. Because otherwise you get a lot of stuff that just spits out onto the command window. So we'll have optim, options, fsolve, the function we're using, and then we're going to just turn display off. So display off, and close that. And so if I run this, initials, if I run this, we get our solutions, which would be 5 and 1. And if you saw the example earlier, we got the same thing. So it would be a y value of 5 and an x value of 1. And so that's how you do it. And if we want to plot that, we can have, we'll go ahead and do that. So we'll have to define our equations. So we'll have dx, so dx equals 0.1. X is 0, dx 2, and then y1 equals 3 dot times x plus 2, and then y2 is minus 2 times x plus 7, and then let's also extract our solutions. So we'll have so y intersect equals solutions 1, and x intersect equals equals solutions 2. And so then we'll have figure 1. We'll have figure 1, and then plot x, y1, x, y2, and then x intersect y intersect. And then we'll make them black circles so we can see the point. So yeah, we got the same thing as in the last two examples, but just using the fsolve function now. And now in the next video, I'll go over a little bit more complicated example, but if you understand this, you'll be at a good place for the next one. Let me know if you have any questions or comments in the comments section, and thanks for watching.